Let's get into the big topic of open source, something that we actually say at Red Hat.
We haven't
This is so
we
awesome.
are an open culture that believes
actually
in
a big
importance of
piece
What is that process that a developer, or let's say a
As the
developer,
Kubernetes ecosystem really boomed,
Good morning, good evening, good afternoon, wherever you may be. You have found yourself once again at the Level Up Hour, where we talk about all things containers, Kubernetes, and OpenShift. So if you are joining us, please do like, subscribe, share, let everyone know that we are here. We don't have any guests today, but I am joined by my esteemed colleague, Jafar Traibi, and we have a very interesting show for you today. And it is something that I don't think is an edge use case by any stretch of the imagination. And that's, how do you move your containers from your desktop, where maybe you as a developer have been dutifully working on your latest project, to production Kubernetes? Well, there's functionality and tooling that actually will help with that. And Jafar is going to walk through a bunch of the steps involved with this, some of the tooling, some of the kinds of things that you need to know. We'll even take maybe a brief demo. And of course, your questions in the chat are always welcome. So, Jafar, welcome.
Hi Randy, hi everyone. Thanks for joining us again. So yeah, indeed, today's show is about the developer experience. So how you start on your laptop or desktop, and then how you can from there go into a full-fledged OpenShift container platform. So yeah, to maybe do you have any questions about the topic in general, or should I just go into maybe a brief overview of what the developer experience has been so far?
Well, let's consider
when
this
speaking about
first.
containers.
Is would you say this is a very typical sort of thing that a developer will find themselves needing to do? Or is it something that depends sort of on how a particular organization handles its dev to prod lifecycle?
Yeah, sure. So that's I think a very good starting point, because so I've been working with customers when I was doing OpenShift consulting for about 5 years. So, and during those 5 years, I've met probably hundreds of customers who were all using different types of technologies and started getting into the container journey. And so for us, from an OpenShift perspective, we were all hyped about containers. I mean, when I started working with Red Hat, it was just the beginning of OpenShift 3, and we started shifting towards Kubernetes and containers. So for us, it was that everything revolved around containers and Kubernetes. But as I went to developer to meet our customers and our developers, I was actually surprised to see that those topics were very, very new to them, actually. So, and even years after we had embraced that, there were still some developers who were still using like the traditional way of doing things, kicking off application servers on their laptop, building their code locally, deploying it locally, etc. So yeah, not everyone was embracing containers as much as we thought it would be like the instinctive way of doing it. But as things started to get more and more, I mean, the user experience was probably something that they had to deal with. So first, there were things like Docker that helped embrace containers and understand how to use the technology. And they first had to apprehend the how to use containers. If you've been using things for years and having your local IDE, everything works, you have your shortcuts, it's you really need to have a very compelling reason to change your workflow, especially as a developer, because you want to focus on your on your code and not necessarily on the the noise around to make your application work.
Right.
So I'd say that Docker had made in the early days a great job in making things easier, and some things happened along the way. They started to have some difficulties in providing a reliable lifecycle for their container engine and stuff like that. And some um, some things emerged in the open source community as an alternative to Docker. So we can think about things like CRI-O, which is like the now has become the default runtime for Kubernetes. We can think about Podman, which is a sort of a command line interface to manage your pods when you are using pods and containers, when you are using um, CRI-O on your local environment, and also things like Builda, which is the open source engine to build your containerized images locally. So basically, the principle was to take what Docker had brought initially, but in a single package, and break it down into very, I would say, focused tools that did just one thing, but did it nicely. So it was basically a separation of concerns.
Yeah, well, I'm starting to get, shades of the old Unix toolbox mentality is, a small tool that does a thing, but does it very well.
Yeah, exactly. So that's and that's basically what we're going to speak about today. We're going to have a focus on Podman. And so Podman, for those who don't know, it is a CLI that has been created to basically act as a replacement for your Docker experience when you are using containers locally. And if you've been using Docker before, it's very easy to start using Podman, because basically they are implementing the same interfaces and same commands, which are basically the talk to the container runtime interface standard. So what I'd like to show you in this episode is
Oh,
how we
steady
can,
on, steady on.
yeah,
So
uh,
before you
yeah, go ahead.
start showing us, I'd like to understand a little more. Is there now a prevailing best practice, or does it remain the case that there are a lot of practices and it's just in such a steady state of evolution that you can't center on here it is the best practice around this?
So there are, of course, some best practices that you need to to follow when you are using containers in general. There's no single way of using containers. There's no way. So think about a very simple example. Uh, if you have a multi-tiered application and you want to containerize that and run that into what we call pods, you have several options, which is the first one is to make everything run within the same pod. You have maybe 3 containers that are going to run in the same pod. It's probably going to be easier to deploy. but it's not necessarily a good practice if your individual components need to be able to scale up and down individually. So there you have the other option, which is packaging your application into separate containers and deploying them into separate pods. So basically, just for something as simple as how do I package my applications or how do I manage my services, you have already those types of questions that you need to ask yourself. If you're doing microservices, are you going to package the microservices with the DB, or are you going to have the DB outside and maybe the API somewhere else, etc.? So
there's
yeah,
an architectural component that you need to consider up front. And usually it's not going to be the case that this is the first generation ever of the thing that you're doing, and you'll have some prior experience about perhaps the particular elements of the application or microservices that are going to need to be able to scale independently, or where there might be some performance bottlenecks or things like that. But it's important not to necessarily take the fastest and most immediate step. It's to think through, well, okay, how is this going to actually run? Do we need to actually separate some things out? Where have we historically seen bottlenecks and things like that? That's what I'm taking from what you just said. Is that about right?
Yeah, exactly. And so let's take another example, and it all depends on the use cases and the type of applications. But say, for instance, that you need to manage state within your applications, and the traditional web or application servers provided ways to manage state out of the box. But if you wanted to be able to scale your components individually and still have this notion of a shared state between all of those instances, because now you're going to run 10 instances of your containers for the same thing, which is probably maybe your front end or something like that. You don't want the user to switch from one container to the other and then suddenly lose state. So now you have to start thinking about things like distributed cache or replication and such things when you are moving your applications into containers. So yes, there are several things you need to take into consideration, and that's probably why developers needed some time before really starting to use containers as such, as a native way of doing their local development. So yeah, or something else, but that's going to be a different story. When you
There
are
always are.
when you are doing so, for example, web development or JavaScript or such things, and you want to iterate very quickly on your local IDE, you have things like hot reload or what we call live reload, which is basically as soon as you hit the changes and save them in your local files, they are immediately reflected into your local application that runs on your laptop. But when you shift to the containerized world, you every time you make a change to your source code, if you are following the, I would say, traditional ways of doing things, whenever you hit a change, you need to rebuild an application, meaning using like Docker build or Podman build or builda, etc. And then this is going to generate a new container image, and then you have to redeploy a new pod from that new image, which takes time, because now, in addition to the build time required for your application package, you are adding that build time for the image, which can be 30 seconds to maybe a minute, and then redeploying the application, etc. So that's a big change in the developer workflow, and that's some of the things that developers need to get acquainted with, which is how you can still have the runtime running in a container, but maybe mounting your local volumes where your code is, so you can have that sort of live reload experience that you would have with with a traditional environment. So yeah, there are many things to take into consideration, and we actually, as Red Hat, have provided different ways to address that, but maybe that can be I would say the content for another episode.
Always, always. Well, and sorry to hold you back because you were rearing to go, but I wanted to actually
Yeah,
get
no
into
worries.
some of those details, and I think a lot of our audience would find it useful to get some of that background. So,
Yeah, sure.
as I think you were reaching for your keyboard, and I was standing
Yes,
back.
exactly. That's what I was gonna do. So I don't know
Prepare
if
for
there are
impact.
any questions in the chat.
Well, let's take a look. So far, so we don't have any. So by all means, show us some stuff,
Okay,
and
cool.
we'll chat some
So
more.
what I'm gonna show you here is basically how to run a three-tiered application. First, using Podman on my local environment, and then generating the assets that I need to deploy that application on OpenShift. Um, so after that, we're gonna talk about some other ways that you can achieve the same end goal, which are not necessarily using those tools, but basically using OpenShift native tools to do that. So the whole idea here is how do I move from my local experience to the OpenShift environment. Okay, so can you confirm that you see my screen?
Yes.
Okay, perfect. So so first thing, let's check that we have nothing running for the moment. So we see that there are no pods. And what we're going to do is we are going to deploy this application. So this is an application that has three components. The first component is going to be a MySQL database.
Hang on a
This,
second. Jafar, could you
yes,
maybe increase the font a bit on that?
sure. Yeah.
So usually
How
when I can't read the text, I assume that it's my
how about
elderly
that?
eyes, but Stabby has confirmed that it's not just me.
How about now? Is it
A
okay?
little bigger, a little bigger. Think about your grandfather. There you go, getting there.
All right. Cool. So yeah, so as you can see, we are going to run three Podman commands. So the first one is going to create the demo database based on MySQL, and it's going to use a container image that we have on Quay. The second one is going to generate an a Python application that injects data points in the database. And the third one is going to be a web front application that's going to show basically some live graphs. So let's go ahead and run the application.
I'm back.
Okay. So now I have the three pods running locally, and I'm gonna check that the application is actually loaded. So let's go ahead and hit that endpoint in here. So yeah, probably needs some time to kick off.
Mm-hmm.
So yeah, let's go ahead and try to understand what's going on in here. So we have the three containers, okay? Let's check that we have a volume that has been created. So we see that we have a volume that has been created to store the data for the database. So that's a first check. Then now, as I would say a developer, I'm gonna try to list my containers to check the logs for those components. So what I want to see here is if the demo web component is started or not yet. So if you know a bit about, so yeah, it seems like it has already started. So I have the application up and running in here. So let's go ahead and pretend that we are the developer locally and trying to access the logs, etc. So how do I do that? And the goal here is to show you, I would say, the local experience and then the experience that you get when you deploy things on OpenShift. So
well, let me pause you for a second, Jafar, because we did have a question, and that is, do you need to open a firewall rule? And
no, so for the moment, I don't have any firewalls. Everything is running locally. As you can see, I am accessing the web component at localhost. And so for the moment, everything is on my laptop. When we are going to expose or deploy things to OpenShift, then we will need a way to access the remote container from the outside world, and we will talk about what OpenShift provides for that. Okay, so let's go ahead and check the logs for our container. So I'm gonna do Podman logs, and the thing here is I want to check the logs for this container and from the demo web pod. So yeah, I can see that everything is working fine. And basically, what we did here is, if you're not necessarily familiar with Podman, if you do Podman pod ps, it's just going to show you your pod IDs. And whenever you run Podman, it has two containers, as you can see here. There's, I would say, a container that we call the infra container, and there's the container that has your application layer on top of it. And if you want to be able to see all your containers, then you have to add those extra commands that say container IDs that basically display all the containers that run within the same pod, right? And how do I know which pod is my application layer? So basically, you see here the ID of the infra container, and that's the same that you see here. So you can guess that the other one is the actual container that you want to look at if you want to troubleshoot your application and understand basically what's happening in there. Okay, so the goal here is also to show you the experience when you are using Podman and how to do some usual things before going into OpenShift. Okay, so now that we have that application up and running, let's switch to OpenShift and try to replicate that demo on the OpenShift server. So here I'm on my OpenShift cluster. I'm already logged in, and I can see that I have nothing running yet in the Podman environment.
It looks like a whole lot of nothing.
Yes. So if you remember correctly, we had a volume. When we were using Podman locally, we had a volume that was created to store the data for the MySQL database, right? So we want to replicate the same thing on OpenShift, And the mechanism that we are going to use is by creating what we call persistent volume claims. And this is going to trigger the creation of a persistent volume on OpenShift. So this is the end result. So you can see here. So maybe I should. So is it easy to read now?
Maybe if we could get a little bigger.
Okay, how about now?
Yeah, not bad.
Okay, so what I have here, you can see that there are some comments here that say this Kubernetes resource has been generated by Podman. And so we're first gonna run it on OpenShift, and then I'll show you how to actually generate those assets from OpenShift. So first thing, we're going to create the PVC. Okay, so so this is going to trigger the creation of a persistent volume claim in here. And once I have that, so it seems like there are some yeah, there seems to be some lag in here, but let's wait a bit for that. So,
Well, while we wait on that, Timothy in chat was saying, please share how we could deploy the image in dev to maybe sit environment.
yeah. So okay, let's see what has been generated for us. So first thing is the persistent volume claim. Okay, so everything has been created now. It seems okay. I have my persistent volume here, and if I look at the pods, I already have also the pods that are running in OpenShift. Okay, so how did we create those? So basically, if you look at the different components that we have, the first one is the demo database, and Podman has generated a pod resource for us that has all the arguments that we need, like the container image, the capabilities, the mount point, etc. So basically, all the resources I need to deploy the container image. So this is a pod. I have the other component, which is the generator. And again, it references the image. It tells which capabilities I need. And the third one is the web environment. So there's something that is specific to this container image. So I picked, I would say, a random image from the internet that we use as an example when you are using Podman, and this image happens to run with a root user, which is not something that you usually want to do when you are using OpenShift. So the best practice would be to rebuild your application to make it use a non-elevated user and run with a different UID. But we wanted to actually just go ahead with the image because we don't have the Docker file for it. And I had to add this item here that says run as user 0 to basically allow it to run as root within OpenShift. So okay, so we have the demo component running, but now let's look at the container, the demo gen container here. It seems like it's not able to start, and nor is the demo web. So let's delete them and Okay, so now that we have the demo database that is running, maybe it didn't find the demo DB ready. So let's create the generator. So now the generator is working, and let's go back and instantiate the web element.
All right, and Jafar, when you get a moment, we do have a couple of questions in the chat.
Sure.
When you get to a convenient stopping place, I'll let
Yeah.
you decide what that is.
Yeah, sure. So now I have all the three components running, and the error that you saw is actually an important one, and I'll be discussing it when we're done with the Podman generate stuff. So as you see here, we are using pods in here, but I don't have yet any service that allows me to access my containers. And to answer the firewall question that we had, we don't have any routes to do that. So what we are going to do is basically, as you see here, we have 3 pods. I'm going to expose the demo web pod. And I'm going to specify the port that I want to expose, which is 8050. So now if we go back to OpenShift, I have a service that allows me to access my container, but I still don't have the route to do that. And we do provide a convenient way to create a route from an existing service with OpenShift, which is the OC expose SVC for service, demo web. And now it tells us that it has created a route within OpenShift, right? So, okay,
now we can see it.
Everything looks fine. We have the application running locally and running on OpenShift, okay? So we have used the resources that have been generated by Podman, and basically the way to do that is very simple. But I think you had a question, Randy, before getting to that.
Yeah, so actually we had a couple of questions in chat, and so one of them was, please share how could we deploy the image in dev to maybe sit environment.
To?
Steph has put it on the screen.
Yeah, as I'm sharing my screen.
Oh, sorry.
Yeah.
Oh, there you go.
So yeah, again, what was the question?
It is please share how we could deploy the image in dev to maybe sit environment.
Oh, all right. Okay. So yes, so this is basically so in OpenShift, the way that we do that is we create what we call a project or a namespace for each and every environment. So for instance, here, I can imagine that this is my dev environment. And if I wanted to have a QA and production environment, basically, I'm going to have 2 additional namespaces, one for QA and one for prod. And I will be able to create what we call pipelines within OpenShift to allow me to basically take the image that has been built into the dev environment and redeploy it to QA, but probably by injecting different environments to that namespace. So that's I would say the principle that we follow within OpenShift. You have your dev namespace, your QA namespace, your prod namespace. You build your image once and for all within the OpenShift environment, and then you promote that application from dev to QA, meaning that you don't rebuild the application, you just use the image that has been already built and deploy it to the other environment. So of course you can do it manually, but the best practice is to have an automated pipeline that allows you to do that.
Okay, and then one other question, which is I think a little bit more fundamental, and that's how did it generate the YAML files?
Yeah. Okay. So that's I would say getting back to our to the main topic of today. So as we see here locally, we have 3 pods that have been generated. Okay, and now we want to generate the YAML assets for that. So what we're going to do is actually Podman generate, and if we look at it, we have 2 targets that we can use. We can generate systemd containers, or we can use kube assets, and that's the latter one that we are going to use. Okay, so what are the options? It says you can generate, so basically Podman generate kube and give it a container ID, a pod ID, a volume name, for instance, or a service if you wanted to expose or to generate the service for your asset. So let's go ahead and generate the kube resources for DemoWeb. And we are going to generate demoweb.yaml, for instance. And now if we look at it, we can see that it has, the timestamp showing that it has just been created, and it's a resource of type of pod type. So it has referenced the image that we used to deploy the container, and it has also referenced the containers that we need to expose. Okay, so it's very straightforward, I would say. You just use the Podman generate kube pod name, and then you have your YAML resources. So now we're going to generate the demogen YAML, and we're going to generate the DB. Okay, so now let's have a look at the database because there's something specific here. If you remember, in the beginning, we spoke about that MySQL image using a local volume, right? That local volume was named MyDB. And in the YAML file that has been generated, it references the MyDB persistent volume claim that should be mounted as the volume that is used by the container image. So the MyDB volume should be mounted at varlib MySQL. Okay, but in this definition here, we don't have the YAML resource to create the PVC, because if you look at what we have generated so far, we have the front end, we have the generator, and we have the database. So now let's go back and list our volumes. So Podman volume list, and we see that we have a local volume called MyDB, and we're going to use the exact same command. So Podman generate kube, and this time we're going to give it the volume name and say pvc.yaml, for instance. Okay, so now if we check the file that has been just generated, it has its type kind persistent volume claim, which means that as soon as I'm going to create that, it's going to create the volume because I have a storage class associated there. And once I have that, I have all the resources that I need to deploy my application. So any questions so far?
No. But we do have a new question in chat, and we'll get to that when you get to a convenient stopping place.
Okay, so is Red Hat recommending Podman over Docker? I would say, yeah, definitely. We have made the shift out from Docker as a runtime a long time ago, and the community in Kubernetes is also using CRI-O as the default runtime for Kubernetes. And this is what we implement in OpenShift. So yeah, I think that's basically the way things have evolved. I would say upstream.
And
I would say
I
that's
think
our
go ahead.
sorry, go ahead. Yeah, that's our recommendation, but doesn't mean that you have to do it.
Well, and I think it bears mention that the Podman project is, Docker aware, in the sense that that a user who is familiar with Docker should be able to transition pretty easily to Podman. That's been a design goal, right?
Yeah, and there are actually a lot of advantages of using Podman, which is basically also, so for example, rootless builds and such concerns were huge concerns if you were using Docker. So for instance, you want to build your applications within a pipeline, you needed to expose the Docker socket to be able to do such things. And that's basically one of the use cases for which we built Podman and Builda and those very specific or use case focused container tools. So yeah, there are a lot of reasons why we recommend that, but yeah, it's probably gonna take a whole show to discuss that.
Well, I like having more shows in the queue. And a good question. Obviously in the container space, we hear a lot about Docker, and sometimes a little clarity around why you might choose Podman over Docker is important. But yeah, I think it's safe to say that Red Hat is pretty squarely in the Podman camp at this point. So do we have some other things we'd like to show or demo?
There are some other things that I wanted to show. So basically what we've spoken about is how you can take your assets that you have deployed with Podman running locally, and how you can then publish those to OpenShift. But if we look at what has been generated, we see here that we have pods. And if you remember the error that we had with the pods that were in an error state that were not able to restart, basically we don't have what we call Kubernetes deployments or replica sets that are managing the error states of the pods to be able to delete them or restart them, etc. Let's see what happens if I delete one of those containers or pods. Sorry. Let's go ahead and delete the demo DB. Okay, so now the demo gen falls into error. So basically, whenever I delete a pod, it goes away. It's not reinstantiated because there's no deployment behind it. And if you are only using pod resources to deploy your containers, this is the behavior, the standard behavior that you get. So now let's see how with OpenShift, without necessarily using Podman. So okay, let's say
actually, Jafar, I think I might have to interrupt you because as you know, we have been invited to leave early this week, so to clear the airtime for the What's New, What's Next podcast that immediately follows. But we actually have a question in the chat from Ravi Sharma, who's saying, would it be possible to show how to extract the whole dev environment YAML files? And would this include SVC and routes as well? I think clearly we're not going to be able to do that today, but I wanted to bring it to your attention.
We are going to be able to do that, but just before that, I'm going to show you something. OC new app, which is basically the OpenShift command line, is going to generate all the resources that we need, and it's going to actually use deployments instead of pods. So basically, this will give us the behavior that we were looking for. So the takeaway here is that if you have the image already stored in a container registry, you can use the OC new app with the Docker image parameter referencing the container image that you want to deploy. And OpenShift is going to create all the resources that you need for that. As for the question that you asked, let's go back to ours. And basically, we have an OC get all -- all -o JSON. Oh, okay. OC get pods. Okay, let's OC get pod demo web -o JSON or YAML, sorry, because that's what you wanted. So basically, I have the running assets which are in the namespace, and basically I can just do that, like OC get the resource -o YAML, and then I have the YAML files that I can store somewhere, and that also includes like the routes. If I want to export the route, OC get route demo web -o YAML, and I have it. So you can also have a shortcut which is OC export all and then -o YAML, and you're gonna have all the resources concatenated. All right, so that's it. Yeah, just here we see that it has been deployed. We have the application. I just need to specify an environment variable here, and it's gonna work.
Fantastic. All right. Well, that was, we had been thinking this might actually be a short show, but in fact, we're sort of down to the wire here with all this information. I hope everybody found it useful, and thank you for your questions. Again, I would encourage everybody to like, subscribe, and share. I'd also mention we had dropped a link in chat a little earlier about how you can pursue more knowledge and information like this from the Level Up program, which includes some of the great training we have at Red Hat. And seeing as how I'm part of the Learning Services organization and run the certification program, we do have certifications that encompass this body of knowledge as well. So do take a look at that link, see if you can maybe learn a bit more about some of these interesting topics. And thank you, Jafar, for a very interesting discussion and demo. Is there
Sure.
Is there anything else you wanted us to kind of leave people with before we got the heck out of here to make room for the next live stream?
Yeah, I think so. Basically, there are different levels of embracing containers. Podman is definitely the first step on your local environment. OpenShift is another step, and the more I would say advanced step is also using like things like containerized environments, which fully run remotely, like code-ready workspaces that we provide with OpenShift. So you don't have to care at all about having things running on your laptop anymore.
Sounds good. All right. Well, thank you again, Jafar, and
Sure.
You will see us again in 2 weeks. So thank you, everybody, and have a great day.
All right. Thank you very much. Bye-bye.